Okay, so today's lesson is on interval notation. Let me just get my paper ready here. We're going to start by talking about notation that we've used in the past, which is inequalities, less than, greater than symbols, and that sort of thing. So if I have the inequality x is less than 5, we would have graphed that previously by having a number line where we would have 5. So I'm just going to make this a simple number line. We'll put 5 there. And we're looking for the set of numbers that are all less than 5. So because 5 is not included in this set, but it is where we need to start our graph, we put an open point at 5. You do not fill it in. And then all of the numbers to the left of 5 also get filled in. So we kind of fill in this dark arrow. And this represents all of the possible numbers that are less than 5. So we start at 5 with an open circle, but 5 is not included. So that's the old way that we would have graphed that inequality. Now, there is another way that you sometimes see to graph these that we've not talked about. The arrow is still in the same place, so let me kind of put that on here. But instead of using a point that's open, they're going to use a parentheses. And the rule is the parentheses always opens the direction of your arrow. So it sort of looks, if you turn it, like an anchor, I don't know, something like that. But that's what it looks like. Now, using this, we often see with this type of graph what's called interval notation. Interval notation uses parentheses and brackets to show you the starting and stopping point for a set of numbers. So you start at the left-hand side of your graph. On the left-hand side of our graph, we have an arrow going off into negative infinity. So negative infinity is where the left side of our graph is. And we put a comma, and it stops at 5. I guess I should label 5. So we put a 5 there. But 5 is not included in this graph. That's just a starting point. And infinity is not actually a number. So we're going to put parentheses around both of those. So it looks a little bit like a point, but this is actually telling a story. This is the left end of my graph, what's happening, and the right end of my graph, what's happening, and you put parentheses around that. All right, so let's take a look at the next one. We have x is greater than negative 2. So to do this one, I would have 2 on my graph. I would have my open point because 2 is not included. 2 cannot be greater than 2. And then we have all of these numbers to the right that are greater than 2. 3, 4, 5, 6, 7. All of those numbers would be greater than 2. So this is the way that we have graphed those in the past. The graph using your interval notation endpoints is basically the same. We have this arrow going off this way, but we have an open parentheses on this end. All right, so again, this opens the same direction that the arrow points. So if I were to look at this one from left to right to do my actual interval notation, on the left end, I've got that parentheses, and it's beginning at 2, which I didn't mark, and so 2 is where it begins, and it ends over here at positive infinity. So we have a couple of different infinities we've talked about. Let me clarify that a little bit. If you're going forever to the left, that's negative infinity. If you go forever to the right, that is positive infinity. Okay, let's go down to the next one. We're going to change things just a little bit. I now have x is less than or equal to 3. I know it's or equal to because there's this little bar underneath. So let me just zoom in on that a little bit. So it's less than or equal to 3. So 3 is the point that we are really considering the most in this. And because 3 can be equal to 3, I fill in the point at 3. That point is part of my set. And then the numbers less than 3 would be the rest of my sets. So it would go this way, 2, 1, 0. All of my negative numbers are less than 3. So I have a filled in point there at 3, and then at this end it goes off to negative infinity. So I'll put 3 on this graph, and it's similar to what we did before, but instead of parentheses, we're going to use a square bracket. So this is where good handwriting and being neat comes in. I don't have the best. But you want to make sure that there's a definite difference between this square bracket and this parentheses that we had up here at the top. So on the left end, this is going off into negative infinity. So negative infinity is on this side of my interval notation. I put my comma. On the right end, it stops at 3, and 3 is included. So we do a square bracket at that 3 instead of a parentheses, because that tells us that this number is part of the set. It's 3 and everything less than. Okay, let's go down to look at the next one. Now I have x is greater than or equal to 3. So we'll go ahead and put 3 on here again. We are including 3, so we will fill in our point. 3 can be equal to 3, and that little bar means equal to. And then we're also including in our set of numbers all numbers x that are larger than 3 or greater than 3. So that would be 4, 5, 6 off into positive infinity. So where point is filled in. On our graph, it's going to look the same. We're still going to have our arrow coming out from 3, but we'll put our square bracket like this. So again, just making sure that your square bracket does look different from your parentheses, and yes, it does matter. So this is 3, and then it still goes off to infinity. So when I go to do my notation, I'm going to have 3 on this end with a square bracket saying it starts at 3 and 3 is included in my set of numbers. And then it goes forever to the right, so positive infinity. With infinities, we always use parentheses because infinity is not actually a stopping point. It's not a place on the number line where we actually can stop and see it. It's just forever off into the future. So they do use a parentheses for that. All right, so next we're going to look at some compound inequalities. So on this one, I have x in the middle, negative 3 on the left side, 5 on the right side. So negative 3 is less than or equal to x is less than or equal to 5. So our interval is in the middle. I only have one number marked here. Let's just make that 0, and we'll put other numbers on here. So let's say that 5 is about here, negative 3 is about here, and we'll just go ahead and set up our graphs. We for sure want to have the numbers in question on the graphs. So where this x is being related to the negative 3, I have this little equal to bar. So what that means, if we're using our just regular points, is that that would be filled in. And 5 is also included. It has a little equal to bar, so that would be filled in. And x is between them. It's all the numbers that are larger or equal to negative 3, but smaller or equal to 5. So it's all the numbers between negative 3 and 5, with negative 3 and 5 being included. When I come over to do my other type of notation, what you'll have is a square bracket going this way at negative 3, one going this way at 5, and then we fill in all of the numbers in between. And so it kind of looks like these are enclosing that set of numbers. And then this also gives us a really short way to write this interval from negative 3 to 5, including the endpoints. So I'd have negative 3 on the left end with a bracket, 5 on the right end with a bracket. So this is telling me start at negative 3, include negative 3, go all the way to 5, stop at 5, include 5. So negative 3 to 5, they would call this inclusive. So we'll write that on there, negative 3 to 5, inclusive is some terminology that you'll see a lot, especially if you look in some of your college textbooks. So negative 3 to 5, inclusive. That means that both endpoints are being included. Okay? Trying to make sure I'm keeping things on the screen here. So let's go to the next one. On the next one I have 2 is less than x is less than 5. This one is different because I don't have the equal to signs. So we'll say this is 0, here's 2, and here's 5. What I would have with our old notation would just be circles at 2 and 5, and everything else filled in between. So these endpoints are open. I don't know if I did that very well. Make them look open. And then it's all the numbers between 2 and 5, but not including 2 and 5. If I do the same thing over here, using my new notation, what I would have is parentheses at 2 and 5 with all of the numbers filled in. And so the parentheses tell me this is my stopping point for the set of numbers, but I don't include 2 and 5 in that set. So it could be like 2.5 and 3 5/8 and 4.99999, but not 5. Okay, so then we have a really cool way to write this. Just use parentheses and 2 and 5. So this would be not inclusive. So it'd be 2 to 5, not inclusive. So that means we have this interval, but we're not including the endpoints. Okay? So let's go down to the next one. We're almost done. So on this one I have a mixture. On the side with the -1, there's an equal to bar. On the side with the 2, there's not. So if I put -1 over here, and let's just say +2's over here, and I have 0 right about there. With our old notation, we would have filled in the point at -1, but left the point at 2 open, not filled in. And then we would have done the space in between. So this is supposed to look not filled in. It's hard to do with that little line through there for the 2. So with our new notation, let me get my numbers on here. On the -1, I'm including it, so I'm going to use a square bracket. On the 2, I'm not including it, so I'm going to use a parentheses, and then we fill it in between. And just remember that these also are supposed to look like they're sort of enclosing this group of numbers, so they're going to open towards each other. And then when I go to write the interval from here to here, I can tell the story using a bracket on the left side, parentheses on the right side, and -1, 2 in the middle, which means -1 is where I start. It's included with the bracket. Go every possible number up to 2, stop at 2, but we're not including 2 in our answer. Okay? If we go down to the next set, we're going to look at a different kind of compound inequality. So if I have x is less than -2 or x is greater than 0, we're actually getting 2 different inequalities that you put on the number line. So let's say 0's here. Let's put -2 over here. So less than -2 would look like this. Open circle at -2, and then an arrow. I'll just make this a little longer, going this way. It doesn't include -2, it's just going off that direction. And then 0, you'd have an open circle at 0 because it's also not included. It does not have that equal to bar. And then we're going off forever this way. So we've done these before. Let me set this up, -2 and 0 on my graph for the new graph. So it's basically the same, except we're going to have 2 pieces. This is x is less than -2, and then this would be x is greater than 0. And I'm using parentheses, rounded parentheses, because we're not including those numbers. It's just smaller than -2, bigger than 0. When I go to do interval notation for this, because it's not one piece of the graph, it's 2, I actually use 2 different interval notations. So on this first one, it goes off to -infinity on this side. So I start with -infinity, and I'm using a parentheses, an open parenthesis, however you say that. for the left end, and it's stopping at -2, again with parentheses. And I'm going to put a U for unite that set of numbers with the set of numbers from 0 to positive infinity. So it starts at 0, goes off to positive infinity. So this means a union between the two sets. Okay? Use a U for union. I know, crazy. All right, so let's go back over here and look at another one. So this last one, I just made one of them including 3 and the other not including 6. So let's say I have 0 here. Let's say this is 3 and this is 6. If I'm using the old way to graph, because there's an equal to bar at 3, I would make this point filled in and then have all of the numbers. Oh, I'm sorry, this is supposed to be, I think this is typed incorrectly. This should be a less than symbol, so let me flip that around. I was sitting there graphing it and then realized it looked funny. So this is supposed to be x is less than or equal to 3. Sorry about that. And then x is greater than 6, not including the 6. So I'd have an open point here with an arrow going off forever. So on this end, negative infinity. On this end, infinity. And then you do something very similar with our new notation. We're just using a parentheses and a bracket. So for the 3, because the 3 was included and did have that equal to bar, I would use a square bracket at 3 and make my arrow. And since the 6 was not included, I just want numbers bigger than 6, but not 6 itself. I would use a parentheses and go off this way. And then just remember, on the left end is negative infinity, on the right end is infinity, and we're going to do another set like this. So I would have parentheses, negative infinity, comma 3, bracket, and that's united, or makes a union with parentheses 6, comma infinity. Close parentheses. Okay, so just a couple of things to go back over at the bottom. If the number is not included, so that would be your greater than, less than symbols, you're going to use parentheses, and if you were doing the old graph, you would use an open dot. If the number is included, so greater than or equal to, less than or equal to, you're going to use the square brackets or the filled in dot. And then just a little note that we always use parentheses for negative infinity, infinity, because infinity is not a stopping point. So you can only use a bracket for a point that you stop at that is included in the number set, since infinity isn't really a place to stop or a number to include. We just use parentheses for that.